Hello, everyone. Good morning, good afternoon, good evening, depending on where you are joining this from. If you are here, you can just type in the chat so that I can see that people are here, and we'll start in a few moments. If you're here, just like say something in chat. Just say hello, say hi. Say something in the chat. Let's see ourselves. Let's get to know each other. Um, Drop your names, drop your location, whatever you want to drop. Um, yeah, it's nice to be here, and it's nice to see everyone and to talk today. Um, it's 2:11, so I wouldn't want to spend too much time waiting for, because I mean there are sessions already ongoing, I guess. So I wouldn't want to spend too much time. So we'll just quickly get right into this. I'm going to be talking about securing cloud deployments using Pulumi's infrastructure policy as code. So before we actually start, let's talk about Sysconf and Pulumi on Twitter. Bring out your phones. If you're on your computer, bring out your laptop. I've put a sample tweet for you here. Currently at Sysconf learning a lot today, and it's time for Adora Nwodo session with cloud security and Pulumi policy as code. Let's get Sysconf, the hashtag there, Sysconf23. Let's get it to at least trend to some certain level. So please bring out your phones, go on social media, tweet that you are at Sysconf. Let's support the organizers. A typical tradition for me to say is to make everyone stand and give the organizers a round of applause. But unfortunately, we can't do that because it's a virtual conference. So, as it's a virtual conference, please, in some way, show your support to the organizers by tweeting about this event and, all of that. So now I will wait for a few moments, hoping to see at least one tweet before we start. Um, I'm I'm hoping to see at least one tweet before we start. Okay, so let's get right into the talk. But before I start the actual talk for the day, I'd like to tell you a short story, what I hope is a short story. And I'd like to introduce you to my friend. Her name is Nkiru. Um, Nkiru is a software engineer. She's working on cloud services at a small social media startup. And in her job, she's responsible for maintaining and enhancing the company's infrastructure on Azure, ensuring that the platform runs smoothly to accommodate different users. So that's it. She's a senior software engineer. She has this serious task, which is to make sure that the platform runs smoothly. So she does a lot of infrastructure engineering, software engineering, DevOps engineering, cloud engineering in general. And that's her role. She has a team that she manages as well. One fateful day, the company decided to roll out a major update to their social media platform, and the updates involved reconfiguring some Azure resources so that they could optimize performance and improve the scalability. So as a result, they had to give Nkiru's team, which is the infrastructure team, and she's the lead on that team. They had to give her team the critical task of reconfiguring the Azure resources so that their platforms could scale better. And this was a lot of work for Nkiru and for her team. And what did she do? She and her team decided to start making several changes to the Azure resources. They made changes to the virtual machines, to the storage accounts, to the network configurations rules, and the different other things. They made like a lot of changes to their resources generally. Because it's a small company, it was very easy for them to go in and quickly make a lot of all these changes without permission issues or without having to go through like three steps, which she felt was a good thing because it made her do her job faster, right? But while these changes were intended to improve the platform, they introduced security vulnerabilities and configuration inconsistencies to the platform, which Inkiru didn't realize was going to happen, right? And this rapid pace of development meant that it was challenging to keep track of every configuration change that was made across the entire Azure environment. They were doing a lot of things, they were moving really fast, they were making a lot of configuration changes at the same time, and it was hard for them to keep track because they were doing this across their different environments, across their different regions, across the different places that they had infrastructure deployed, right? They deployed the change, but soon after the update was deployed, the company's incident response team detected anomalies in the system's behavior, and there were multiple high severity security incidents. Users were also reporting unusual activities on social media, and there were signs of potential data breaches. Imagine people going on Twitter and saying that something is down, and imagine you being the reason why something is down. I said something on YouTube 2 years ago when I was like that. Don't let your company trend on Twitter for the wrong reasons because of you, because they might sack you. And this exact scenario was what was happening to Nkiru at that time. And panic sets in as the company's reputation was on the line. The on-call engineers were figuring out what to do to salvage the situation, and they temporarily mitigated the situation to reduce the customer impact. But they mitigated the issue; they hadn't completely resolved the issue, which is still a problem, right? So while the incidents were temporarily mitigated, just so that they could reduce customer impact and the security problems could go away for a bit, they had to really understand where the issue was coming from so that they could properly resolve it. And obviously this could help with like postmortems, this could help with like um sorry and yeah, this could help with like postmortems, this could help with them understanding the situation better so that they could handle it better. Inkira and her team were summoned to investigate the issue, and they spent days trying to figure out what was happening. They were going through the entire Azure portal trying to identify the root cause of the security breaches and the inconsistencies in the configurations. It was time consuming and it was a stressful process, the same way initially updating all the different configuration settings was time consuming and stressful for Nkiru and her team generally, because there were a lot of things that they were doing manually in the portal by themselves. And obviously, as this was happening, the pressure to resolve the issue was quickly mounting, and Nkiru was worried that God, I beg, she doesn't want to lose her job. What do I do? What do I do? And during this crisis, Nkiru began to reflect on the concept of policy as code, which she had heard about in different tech discussions prior to that period when she was supposed to do that task, right? Um, Policy as code typically offered a way to define, automate, and enforce security policies within the Azure environment or any other kind of, cloud environment, to be fair. And then she had this aha moment, and it struck her that if we had implemented policy as code rather, from the very beginning, I would have prevented all these misconfigurations and vulnerabilities that have caused all these security breaches. And now I feel like I'm about to lose my job. They're about to sack me because something I heard in a tech conference I didn't apply in my real life when I had the chance. And it would have been a great opportunity for Nkiri to apply this because she worked in a startup that didn't have an in-house security team. She was leading the infrastructure team, meaning that she had multiple places and different areas to make impact. But this sort of flew over her head and it almost cost her her job. Now, determined to resolve this issue and prevent these different kinds of incidents from happening in the future, Nkiru and her team decided to implement policy as code in their Azure environment. They defined a set of security policies and configurations as code, and they leveraged, the Azure policy to automate these compliance they leverage the Azure portal rather to automate these compliance checks and enforce these policies across their resources. With policy as code in place, they could easily identify and rectify any violations and ensure that feature configurations are adhered to their security standards. So this was like a learning opportunity for her. She fixed the problem and, by implementing policy as code, and with that she identified that this was why it went wrong. We misconfigured some things and this cost us some things. So now we have implemented this security policy so that next time me, any of my team members, or anybody we hire in the future wouldn't make these mistakes, because now there are policies that must be enforced rather, to make sure that we adhere to certain security standards, right? And as a result, she resolved the crisis, but this also meant that she was future proofing a lot of things in the infrastructure, in the security side for their infrastructure. And this means that it significantly enhanced the security and consistency of their Azure environment. And Nkiru's decision to adopt policy as code transformed the company's approach to cloud security. The incident served as a valuable lesson, highlighting the importance of proactive measures like policy as code to secure cloud deployments effectively. And Kiro ended up getting a promotion from this unfortunate event. And it was amazing for her because her expertise, leadership, and swift adoption of innovative solutions saved her company's reputation, but also reinforced her position as a trusted senior software developer in the organization. Her story became an inspiration to other colleagues, and this encouraged them to embrace modern practices for securing cloud deployments, as well as best practices generally in the context of software engineering. And she turned what was supposed to be a very big problem that could have cost her a job into an opportunity for her to get a promotion and shine through at the end of the day. But let's be honest, Nkiru could be anyone and everyone. But at the same time, not all of us would be as lucky as Nkiru if that ever happened to us. What this means is that every one of us has the capacity to fall into a problem like this. It is possible for any one of us to fall into a problem like this. And some people might lose their job, actually get fired even if they fix the problem. Some people might stay at their jobs and they will be put on some kind of probation. Some people might get other kinds of problems out of it, face some kinds of consequences. But not everyone will turn out to get a promotion from this like Nkiru did at the end of the day. And that's why, for me, it's important to learn about these security concepts. And that's exactly what I'm going to be talking about in this presentation today. So, hi, everyone. My name is Adora. For those of you coming, you are welcome. I'm a senior software engineer, currently helping developers build healthier cloud infrastructure, build more robust cloud infrastructure, basically. So I work in the context of cloud engineering and developer platforms. I'm the founder of Nexus Scale, which is an organization currently, a non-profit organization currently helping people start and scale their tech careers by connecting them to opportunities, work experience, and other opportunities that might not necessarily be like work experience, but still very useful to you, like projects and things like that, right? So I'm a multi-published author. I have 2 books on cloud engineering, and there's a lot more from where that came from. Digital creator as well. I do a lot of content creation on Instagram a lot nowadays, and I create some courses as well. I used to do YouTube in the past, but I'm no longer as consistent. But I'm coming back soon, and you'd hear more about that. I'm also a global speaker. I speak at conferences all around the world. Recently, earlier this year, I counted the number of conferences I've spoken at since I started speaking, and I realized that I've spoken at over 120 conferences since I started, which I think is a funny thing. But I'm done talking about myself now. Let's get to policy as code. Policy as code, the idea of policy as code is like using programming languages or any kind of language, really, whether it's a programming language or a domain specific language like a DSL or even a markup language to define and enforce what can and cannot be done to a system. So you define some kind of policies, and it is like, okay, if you are going to run this kind of infrastructure, I want you to be able to do this. And if you define a policy that says, I don't want my, let's say, a storage account in Azure Cloud. I don't want my storage account, my account policy to be open to anybody just to use, right? I want my storage account policies to always be set to none. And somebody else is coming to talk about setting the policies, the authentication policies for like the storage blob or the storage container. The policy would cry and return an error because the policy is not supposed to allow anybody to have direct access to that storage account. So like things like that, right? I only want to be able to deploy resources in West Europe because as a team, we should not be dealing with Southeast Asia or West US. Or let's say we are primarily a UK startup, right? And what this means is that we have to adhere to like GDPR rules, for example, right? And what this means is that there are many things under GDPR, but I'll just use one example where you can't store the information of someone in Europe in a data center that is outside of Europe, right? So if you are doing things like that, you want to enforce policy as code so that all your resources, all your VMs, all your databases are declared in regions that are in Europe. So East Europe, West Europe, all the different regions where the data centers are. So you can write a policy to make that enforcement. And if anybody goes to try and create a data center, sorry, if anybody goes to try and create a VM, for example, in a data center that is not in Europe, it should not allow, the policy should reject that request. So that's basically what policy as code is. You're writing those commands and you're able to do that. So it's like a decision making logic for your system and it's automatically applied. So this is how policy as code typically sort of works, right? There's a compliance team that probably writes the policies, and these policies exist in some kind of policy engine, and people can, you can query the policy engine, and the policy engine should give you a response. So typically, a command to create the infrastructure before it goes ahead to go and create the infrastructure or manage the infrastructure or modify the infrastructure, whatever, it goes through that policy engine to verify that these IAC commands actually can be validated through the policy, and the policy allows these things to run. And obviously, after that, you get a response. So it's either you get an error saying, I'm sorry, no, I'm not going to allow you create this, or you get a warning that is like, I typically don't mind you creating it, but please don't, right? Or it's like green all the way, go and create whatever you want to create. And the policy allows you track these things. And it's very important because there are different challenges in cloud security at the end of the day. Scale and complexity of modern cloud infrastructure is a thing. It's like the cloud is becoming complex and it's becoming easier because people are building tools that make those complex things easier. But what this means is that as we solve old problems, we sort of introduce new problems as well, right? And these are problems generally for us because attackers don't care about your innovation. They're constantly looking for ways to steal customer data, to use whatever they steal to be able to get money. So you want to make sure that you don't fall into those problems. Another challenge is the consistency in security policies. At the end of the day, if the security policies exist only in my head, and when I am or exist maybe in a document, but obviously I'm a human being, I can choose to follow or not follow those policies, or I might just mistakenly forget, or I might not even create the resources the right way because I don't have time to follow all the policies through and through. So let's say for one particular region, I create the resources the right way, but for another region, I make a mistake and I don't do it in the way that it's supposed to be done. That's also another challenge. As our infrastructure as well is changing, we're seeing rapid changes in our IAC. People are growing their businesses, and as a result, they are getting more customers, and they now need more ways to handle the load that the customer traffic is bringing. So they are going through rapid infrastructure changes. This can also introduce security challenges if we don't go about it the right way. Collaboration as well. Like, you want to make sure that your engineering teams, your platform teams, your on-call teams, your security teams, every single team is collaborating, because you don't want people working in silos. Imagine a security team creating some kind of security policy or compliance rules that can be applied by the engineering team at that particular time because of some kind of architectural constraint. So you want to make sure that there is collaboration, and you also want to make sure that there is some kind of compliance as well. So let's look at this code, right? This is a policy. I've been talking, and I'm hoping that people are wondering what policies are and how you can define policies. How do you write policies? Do you write them in YAML? Do you write them in English language? How do you write them? This is a policy written in TypeScript, right? And this policy is basically saying that I want to ensure that my storage accounts use secure transfer. So basically, if I have a storage account, an Azure storage account, and one of the properties is not enable HTTP traffic only, it should cry, right? And if you look at this code, you can see exactly where this is happening. So this is a policy written in TypeScript. And with that, I just want to talk a little bit about Pulumi and introduce Pulumi to this conversation, because Pulumi is the tool that is helping us write this policy in a way that is familiar to us, because ideally and originally, policies are written in languages that programmers don't have the head for and can be stressful. So let me just talk about Pulumi for a bit. It's an open source infrastructure as code platform that enables developers and operations teams to define, deploy, and manage their cloud infrastructure and applications using familiar programming languages. Meaning that if you are trying to do DevOps, you can use Pulumi, and you can write your DevOps things in JavaScript, in TypeScript, in Go, in Python, in YAML, in C#, languages that you are actually familiar with. It provides a framework for codifying infrastructure, and it makes it easier to provision and manage cloud resources while you're leveraging the flexibility and expressiveness of regular programming languages, as opposed to using languages that force you to adhere to a particular style. And this is what Pulumi looks like. Like I said, you can create different language. You can create like infrastructure declarations with different languages. Here you can see TypeScript, Python, Go, C#, Java, and YAML. So these are like the languages that you can use with Pulumi today, meaning that if you're a TypeScript person, there's nothing stopping you from starting, getting into cloud or DevOps engineering today. If you do Python, if you do Go, C# or Java, the same thing as well. And I just want to state that prior to my Pulumi discovery, I was a software engineer. Today, I'm able to work as a software engineer, an infrastructure engineer, or a site reliability engineer just because of my exposure with Pulumi. So let's talk about a few advantages of using Pulumi. Like I said, the transferable skills. You can be a software engineer and still understand some of the cloud things. You can become like an infrastructure engineer and still be a software engineer because you know programming and you're able to use Pulumi to provision infrastructure. You can do custom policy creation as well. So Pulumi allows you to create custom policies for your policy as code declarations. You don't have to stick to a particular framework or a particular model. You can create different custom policies based on your organizations' compliance requirements. Pulumi has multi-cloud support, so they support a lot. I can't even think of a popular provider that Pulumi doesn't support right now. It's insane. I know that they support AWS, Azure, DigitalOcean, Google, Vercel, different things, MongoDB. Like they support like a bunch of different clouds or platforms, and you can do infra for them, writing regular programming languages. You don't have to go and write things that you don't care about. They integrate well into your CI/CD pipeline, and they have a vibrant community, which I am a part of, obviously. How does Pulumi enforce security? It allows you to define policies directly in your infrastructure code. So you can specify rules and constraints for how resources should be provisioned and configured. And I'll show you that in a bit, just so that you can see this happen in real time. The policies can include requirements relating to encryption, access control, network security, and compliance standards. I talked about GDPR initially. So an example of a policy would be, because we are a British business or a German business or a Spanish business, right? We are in the EU, for example. We have to adhere to the GDPR requirements, meaning that we can't be provisioning infrastructure in data centers that are not in the EU. So we want to enforce a policy that makes sure that any VM, any database, any serverless architecture, any service bus, anything you create is in the EU. You can't go you can't use any data center that is not in Europe, right? So some standards like that. And by embedding the security policies in your infrastructure code, you ensure that your security measures are consistently applied and they are auditable. Pulumi also supports custom policy enforcement. I think I've talked about this before. It enables you to write custom validation checks and compliance rules as part of your infrastructure code. So you can define checks to enforce security best practices. You can ensure that all your Azure storage containers are configured for server-side encryption. You can ensure that all your virtual machines have the latest security patches. You can ensure that, like I said earlier, your Azure storage accounts, for example, are also only, using security transport systems. Like there's no thing of like I'm only using HTTP, like I'm only using HTTPS, I should only be using HTTPS and things like that, right? You can enforce these things. Anything at all that you feel is an important thing to enforce, you can go ahead and do that with those security policies. And Pulumi also encourages collaboration between development, operations, and security teams, because now people, obviously this would also depend on the culture of your team, but the tool that is Pulumi makes it easy, because now security teams can write policies in programming languages that engineers can read and understand. Engineers can also be a part of the policy creation process, and people are able to now read those policies and enforce them when they are creating and managing their own infrastructure, right? You can collaborate to define those security policies, and these security considerations are integrated into the development and deployment process from the beginning. So now, in doing this, the magic words are Pulumi policy new and Pulumi policy publish. And let's see the code. So one thing I'm going to do right now is I am going to move over to GitHub, just so that you can actually see this happen in real time. I have like a GitHub tab open that I can show. So I'm in GitHub now, and I'm hoping that you people can actually see my screen, right? So yeah, let's go. So this is the policy as code demo that I created. I just did it for like a serverless application. So there's not so much in terms of infrastructure code happening here. All of this infrastructure code was created by Pulumi. and I could actually do so. Please, quickly in the chat, if you want me to do this thing live right now, can you type do it live? If you don't want me to do it live, let me just walk you through GitHub, whatever works for you. Okay, people are saying do it live. Wow. Okay, fine, fine, fine. I'm going to do it live. Okay, so I am going to open a new window in like VS Code. I think at this point I'm just going to share my entire screen. It makes it easy instead of sharing different things. So yeah, I'm just going to share my entire screen, which I'm doing now. And I am yes, I am in Visual Studio Code. So now I'm going to have a new terminal and I'm just going to go into source, right? And I'm going to do I'm going to raise this up as well so that people can even see more. I'm going to let's call it sysconf, right? Make sysconf and I'm going to cd into sysconf. So now the next thing I'm going to do is I'm going to create my first Pulumi project because I need to have a Pulumi project first before I can start doing any policy as code thing. So let's do Pulumi new Azure serverless Typescript. I hope this is correct. If it is not, it will fail. So yeah, let me run Pulumi new and I can see the different things that it can provide to me because I'm not sure I remember the name. So yeah, Pulumi new Azure. Yeah, there's so many. You know what? I'm just oh okay. Yeah. Okay. I think I've changed something new. Yeah. So I think yeah. So source, cd documents, source, sysconf. Um, I have done this before. So yeah, serverless Azure Typescript. I mix it up in my head. Wow. Okay. So yeah, let's just so I've created the project name is going to be sysconf. The description is this, the stack is this, all of that. I want it to be Azure serverless. So it's asking me for like, oh, what's the path to the folder where the app is deployed? What's the name of the error document? What's the name of the like main document? What's the path for the folder containing the website? So it's asking me all these different configurations. Like typically how when you want to create a TypeScript application, it does like a lot of boilerplate for you, right? So it's creating all of my boilerplate right now, and let's wait for it to be done. It's going to be done in 1 second. So yeah, let's wait. So now we have that, and I'm just going to actually open the folder for you people to see. So document source sysconf. I'm going to now I need to do the terminal thing again. So now this is the Pulumi project we just created. We have a pulumi.dev, which is like a configuration for my dev environment. If I let's say I go and I do like I'm in sysconf right now, I can do a Pulumi stack init production. It's going to create a production stack for me. Now I can have a pulumi.production.yaml, and if I want to make it appear, I can just set a config there. So let's say pulumi config set app path. Someone should give me their name. I can't see my screen right now, so let me just use somebody else's name. Let me say Grace or something. And now my pulumi.production.yaml has appeared and Grace is one of the configs there, right? So we can actually just put all of these configs into this, but we're not using production to do anything. I want to make sure. Okay. Pulumi stack. Huh. Okay, I need to hide this. Okay. Yeah. Pulumi stack. I want to make sure that I'm on dev. I don't want wala. Okay, so I'm back on my dev thing. I just wanted to show you people this for a bit. So in index.cs, that's where the infrastructure declarations are, right? And as you can see, we are importing all the configurations. We're creating a resource group. We're creating Azure Blob Storage. We're creating the websites in the Azure Storage accounts. We're creating, let me go down to the function app where we're creating the function app, like right here. You can see that. And then we're exporting all of the configs and things like that. So this is like the boilerplate that Pulumi has created for me. And as you can see, everything is created. Everything is TypeScript, pure TypeScript code. As me, that is a DevOps person and an infra person, I am not writing other languages or domain-specific languages that I'm not supposed to be writing or care about. I'm writing pure TypeScript. So this is amazing. It's just TypeScript code. So now let me create another um, directory and call it policy. So now we have policy, and I'm going to cd into that policy directory. So now we have policy, and I'm going to do Pulumi policy new. And it's going to ask what kind of policy do I want to create. I want to create Azure TypeScript. So I'm going to just scroll down to Azure TypeScript, and like it's created the Pulumi project for me. It would also create the Pulumi policy project for me. And I'm just going to show you something real quick. We're only just going to do one demo so that we can actually go, because I think my time ends in 2 minutes if I am not mistaken. That's if my time hasn't even, like, at this point ended. But I hope you are still here. Let's go till the end. And these are things that just typically help you stay secure, stay compliant. Because as human beings, let's be honest, we forget things, right? We're always going to forget because we're human, right? So we need a way to enforce these rules. It's like having style guides. So in your company, you can't mistakenly use spaces when they're supposed to use tabs and things like that. Imagine having security style guides as well that enforce these rules for you. So now we have those policies created. NPM has told us that we're done. So we can come here and we can see that we have our Pulumi policy pack projects. We have our index, which is actually our policy. So we have this policy written, and this policy is actually for storage accounts. So it said, if the public access for the container is blob or container, then we should have a problem because we only want public access to be known. Like we don't want anybody to have public access, and that's what I was talking about. We don't want anybody to have public access. So now let's go to the storage accounts in this our deployment. The public access here, this to the for the container is none, right? So it won't fail because it is not blob and it is not container. So now let's actually try and run this. I need to go back into the main. So let's try and, yeah, let's try and run this. Let's say Pulumi preview. So it's going to be Pulumi preview is how you check the resources you're supposed to be deployed. But I'm doing -- policy pack, and then I'm going to put the path to my policy. The path to my policy is in /policy. So Pulumi preview -- policy pack. So I'm basically saying preview all my Pulumi resources, tell me the ones you are going to create, and also validate it in this policy, like with this policy pack, the policy pack in this policy folder. So everything should work fine because public access is blob and public access is not blob or container. Public access is none. So everything should work out. You should see the preview. It would preview everything and everything should work fine ordinarily. So let's wait for the Pulumi preview thing to happen. Let me just make this bigger while we wait for Pulumi to answer me. Okay, so did I do Pulumi preview or Pulumi up? Okay, I did preview. So I'm not going to create any resources. It's just going to preview those resources and tell me the ones that would get created based on what I wrote down in my code. So it is previewing that. I wish this could be faster. Okay, so it's telling me that I will create a resource group, a storage account, an app service plan, static website, a blob container, a blob, and all these things. It's telling me these are the things I will create if I go ahead to run this deployment. Now, let's say that I change this policy. I say if the policy is none, because what we have here is none, right? Our storage account public access is none. So let's say I say something like, if the policy is none, it should tell me something like Azure container should have, people should have access to the Azure storage container. Let me just say it like that. People should have access to the Azure storage container. You should report that. You should report the violation, right? Because I'm violating the policy. So you should report that. Right. So report violation is how you say throw this error. Like you know how you do if statements and you can throw errors and you can catch them in regular programming. You can report a security violation. So now let's run this again. Seeing that this code, the public access is actually null for the storage container. And here we're saying that if the storage container's public access is none, that it should report the violation. So now we expect that this preview cries. Hopefully he cries and I don't embarrass myself. Let's wait and see. Yeah, so the preview is also taking its sweet time, but let's see what it says very soon. I'm 4 minutes over. Yes. Okay, so it has come back and it has cried. It said, based on this policy, it prohibits setting the public permission on Azure storage blob containers. People should have access to the storage container, which was what I said here. And we set this to none. So this is working and I did not just embarrass myself. So yes. So now there are questions in the Q&A. Okay, I'll go to the Q&A. But someone is asking here, where is the TypeScript policy deployed? So you can also run something called Pulumi policy publish, right? And if you maybe have, so Pulumi is open source, right? So if you are using like the open source version of Pulumi, you can deploy your policy to the, all right, if you're using the enterprise version of Pulumi, you can deploy your policy to the Pulumi cloud and manage that policy there. If you're using the open source policy, the Pulumi policy thing, you have to deploy your policy to your own cloud where you are managing the thing. Or you can keep the policy juxtaposed with the code, right? And when you are running your Pulumi up, you can do the same thing I did, where Pulumi preview dash dash policy pack, and you put the name there, the path there, because all your policies will be in the same repo as your infrastructure code. So you can deploy it to the cloud and call it from there, or you can leave it together with your code and just reference it via file paths. It is pretty much up to you. So someone said, is Pulumi similar to Terraform? Pulumi is similar to Terraform, but Terraform forces you to use a programming language that is their own, while Pulumi allows you to use any programming language of your choice, which I think is amazing, right? And Pulumi has like a ton of providers as well, and a ton of things that they provide. And Pulumi is open source, right? That's how it's different from Terraform. Someone is saying, apart from being able to use other languages with Pulumi, how is it different from Terraform? I already stated, variety with providers, using another language of your choice, and open source. Recently, Terraform changed their license, so technically they're not open source anymore. Pulumi is still open source, and for people like us that just want to practice and try things out necessarily without paying for an enterprise version or all these kinds of things, you can just take a stab at Pulumi, visit their website. You don't have to use a paid version or go into a trial version of the thing. There's a completely open source package waiting for you, and they have like a ton of really helpful people in the community, like I said, which I am a part of. Can Pulumi move a resource to a state from a state that was not initially managed by Pulumi? Case of when your infra was originally managed manually. Yes, so you can do Pulumi import. So you can import your infra into the Pulumi state for Pulumi to manage on your behalf. I mean, people migrate from different providers or from manual configurations to Pulumi all the time, right? So Pulumi has a mechanism. Unfortunately, it's not part of this talk, but I can tweet about it. I can share links for migrating to Pulumi from like a different provider, if that would help you. But yes, Pulumi can move a resource to it, like into its own state when it was previously managed by a different provider in a different states. Yeah, those are all of the questions. Thank you everyone for being a part of this and for listening. I'm going to drop down my GitHub link in the chat because I actually created like a demo for this, but we ended up not using the demo because I ended up doing it live. But it's on GitHub. You can go check it out and understand it further. I think the README as well sort of like explains what's happening in the code. So if you go through the code, go through the README, it would help you out. Yeah. Thanks everyone.
Thank you so much, Adora, for your session. It was amazing. And like doing a live demo, that was crazy.
I
And it
was
went
afraid
well.
that I was going to get embarrassed, but
So you didn't.
that didn't
But
happen.
yeah,
Thank
that
you.
was
Thanks,
fun.
everyone.
Thank you. I really enjoyed it. All right. So you already answered the Q&A. Amazing. I'm just going to tell everyone else that we have about a 35-minute break till the next session. So please feel free to use the Expo booth. Money Point is there, Convoy is there, network. And also there's a separate networking panel where you can do speed network. That would be like really amazing. Just click on it and then you'll be matched by some random person and you can make a new friend. So, all right. See you there. Bye.
Okay. Bye.